All right, welcome back to Math AH. This is our second half of our 6 points 1C part. We did the first part last time. So we have to go back from what we summarized last time. We have to remember when we have side information, it's going to force congruent triangles. The side included angle side force congruent triangles. The angle included side angle force congruent triangles. But side not included and angle did not force congruent triangles. Remember, on the side not included angle, one of the sides is not locked and can swing to two different positions. Where on the angle, you can make triangles that are larger. They're similar, but not necessarily congruent. So we're going to use that information today to work on number 4. It says determine if the given conditions would produce a unique triangle, only one triangle, or more than one triangle can be made from the given conditions. Circle one unique triangle or more than one triangle. So we have to look at what's given and decide which situation we have. A triangle with sides 8, 11, and an included angle of 45. So I have to remember that it's saying included angle. Included means that the 8 and the 11 are locked in by that 45 degree. So we have an 8, 11, and a 45. That means there's only going to be one way to do that triangle. I recognize that I have side, included angle, side. The next one, a triangle with angle, angle, angle. Well, I know that's going to be more than one triangle because I can make triangles that are larger and larger and larger but still have that same angle measurement. So look at C and D, pause the video, and try C and D, and then turn it back on when you're ready. For C, you should have got one unique triangle because here I see side information. On the next one, we have a non-included angle. That's side angle information. That means we have a swinging side. It can go in two places, so that would be more than one. All right, for the next part, we need our protractor and a ruler, or if the protractor has measuring parts on the bottom, then you're good to go with just that protractor. So make sure that we pass out the supplies. Again, you're on a computer screen, so your length may not be the same as the person next to you because you might have zoomed in or zoomed out, but your angle measurements should align. So go ahead, pause the video, measure these triangles up, write down their measurements down here, and then we'll talk about some relationships we see within the triangle. All right, well, here's the measurements I got. Now, your sides might be completely different than mine because you might be more zoomed in or zoomed out. But BC, no matter what your sides are, should still be the smallest of the sides. Your angles should be pretty close to the same. If they're a degree or two off, fine, as long as the three angles themselves add to 180. Same thing with over here. Your side measurements might be off, but EF should still be the smallest side. And your angle measurement should be one or two of mine, but as a sum, they should add up to 180. If you got something wrong, check with your partner, have them help you measure. All right, so number 7, describe the relationship between the location of the longest side and the largest angle. So let's see. Let's look at the largest side, longest angle. So here on my left triangle, my AB is my largest side, and my 90 is my largest angle. On my right triangle, 5.9 is my largest side, and 120 is my largest angle. And I realized that the largest side is across from the largest angle. Okay, and then it says describe the location of the shortest side compared to the smallest angle. All right, so same type of thing. I'll pick a different color to work with here. My smallest angle is 33. My smallest side is 3.2. Over here, my smallest angle is 20. My smallest side is 2.4. Once again, the smallest angle is across from the smallest side. Therefore, the medium angle will be across from the medium side. Describe the location between. So summarize your findings. The smallest angle is across from the smallest side, shortest side. Okay, I'm going to control copy and just switch a couple words. The joy of being on a computer. The middle angle is across from the medium side. And the largest angle is across from the longest side. Again, we're on a video. If I'm going too fast, pause it, rewind it, slow it down.
You can do it.
Next page. In the following triangles, fill in the missing angle measurements and list the sides of the triangle in proper notation from shortest to longest without using a ruler. Note, triangles below are not drawn to scale. Okay, so on 9, all the angles are filled in. So if I want to know my smallest angle, 41 is the smallest angle, so CB is the smallest side. 44 is the medium angle, so AB is the medium side. And then 95 is the largest angle, so AC is the largest side. So I'm trying to list the sides from shortest to longest. Okay, we're talking about a measurement here. So I know the measurement of CB is smaller than BA, which is smaller than AC. Okay, so this is a length. The length is smaller than a length, which is smaller than a length. If I wanted to say the segments, I wouldn't be putting inequalities. I would just say CB with my segment mark, then BA, then AC, like so. So either way, you can either put measurements with the inequality or you can list your sides in segment notation. Okay. The next one, if we know two angles, we can find the other angle. 63 plus 57, we're at 120. We got to get to 180, so what's missing is 60. So if you have two angles, you can figure out the third angle. Then I can put them in order. Smallest, medium, largest. Then I can put the sides in order. Smallest, medium, largest. Then I can list them. Okay, so CA length is less than B's length, which is less than AB's length. All right, pause the video and try number 11, and then we'll look at it. All right, check your answer. I got CB is less than BA, which is less than CA. Okay, so we went from angles to sides, but we can also go from sides to angles. So this is just going in the reverse order. In the following triangles, list the angles of the triangle using proper notation from smallest to largest without using a protractor. Note, the triangles are not drawn to scale. All right, so I still just have to go, okay, 13 is the largest, 12 is the medium, 5 is the smallest. So I'm going for the angles across. So I know the measure of angle ACB is less than the measure of angle BAC. Remember, it doesn't matter which ones are the endpoints. You can say CAB or BAC, but it matters that A is in the middle, which is less than the measure of angle ABC. Okay, so same kind of concept. You try number 13 and then check your answer. Okay, so here I got the measure of angle BAC is less than the measure of angle CBA, which is less than the measure of ACB. Now, because you don't have 3 rays coming off of one vertex, you really could just name it with one letter. That's fine in this situation. So you can say angle A is less than angle B, which is less than angle C. That would be perfectly fine. All right, here we have got a problem. Both of these are the same. So if both of these are the same, we have an isosceles triangle. That means that the opposite angles are also going to be congruent. So we have 2 that are congruent, and we have 1 that is not. These 2 are same, and this one's larger. So when we write our statement this time, we're going to say that angle A, the measure of angle A, is equal to the measure of angle C, which are both smaller than the measure of angle B. All right, hit save and turn that one in.